Hello engineers, welcome to another video on low level design. In this video, let's look at another creational pattern. This is called the factory method pattern. I hope you're ready. Let's get started. So let's first start with the intent. The intent of this pattern is define an interface for creating an object, but let subclasses decide which class to instantiate, right? So there will be situations where the parent class will not know which type of object to create. So in such situations, we can refer to this factory method pattern, which will take care of creation of the object and it will return back the object and the client can use this object to perform other operations. So let's take a look at some of the examples. So this pattern is seen in many libraries. For example, in UI libraries, we can see this. For example, if you have ever used a UI library like Material UI, you can make use of many components, right? Like buttons, text boxes, text area, tables, and many things like that. So if you take a look at the button, you can have the base button class, but there will be so many variants of this class. There'll be an outline button, there'll be a filled button, text button, icon button, and so many variants. And depending on the inputs, the kind of button that will come out will change. So in such kind of situations, we can see the implementation of factory method. And another example is payment methods. So whenever we are trying to make any payment for any type of order, we have so many choices. And depending on the choice that the user selects, we have to create the respective payment processing object and then process the payment accordingly, right? So we don't know the payment method up ahead. In such situations, we cannot keep all kinds of objects created and be ready, but we'll create it at runtime, right? And we can also see this during document export. So when we have applications where we can export data into multiple formats, maybe Excel or PDF or any open source document. So we have this choice of documentation, right? In such situations also, we can see this pattern being used. And if you have ever used Uber, you know that you can make a choice between the type of ride, right? Mini cab or a sedan or a 6-seater cab and so on. So depending on the type of ride, we create the ride object and then that can go into further processing. So in these kind of situations where there is a choice from the user, we can make use of the factory method, right? Now let's have a look how this factory method pattern is implemented. Let's go to our UML. So I have added a new file called factory method in the design patterns folder. The link is available in the description below for you to check it out. So let's go into the diagrams. So this is the class diagram for the factory method pattern. Let's have a look at it. So on the left side, we have this product related stuff. Let's have a look at this. So we have a generic interface called product, and this is being implemented by multiple products. So there is product A, product B, product C, and so on. And there can be any number of products like this, and they all need to implement the operation method. This can be any operation. For example, if we have the button class, there can be a text button here and icon button here and so on, right? And they all implement the on-click method. So this is the product. And to create one of the products, we make use of factory. So this is the factory side of things. Now let's see what is the factory. Factory, this can be an abstract class or an interface like this. And this factory class has one method, factory method. It can be any name that you want. And it returns one of the products. So since this is an abstract class, some other class will be inheriting from this and implementing the factory method. And in that factory method, it returns that respective product. For example, if I want to create a text button, I will have a text button factory here, which will return text button as a product. And if I have an icon button factory, this will return an icon button product and so on, right? And there can be many products like this. So if the type of product is not known in advance, we can use this type of pattern. As you can see, this is pretty open for extension because we can keep on adding factories and products, and we don't need to change the parent classes for this. So this type of pattern is called the factory method pattern, right? Now let's see the sequence in which the operation goes. Let's say we have a client and client wants to create a product A object. So the client will call upon the factory method on the product A factory, which will create the product A for it and then return the instance. And after the client has the instance, the client can perform any number of operations and do the result, right? If we go back to the class diagram, we can see here, client will call upon one of the factories and that factory will return one of the products. And in that product, there are operations and the client can make use of these operations. So this is the typical implementation of a factory method pattern. Now let's see this using an example. Let's say we are building a payment processing system. And on the left side, we have the payment processor, which is our product. And there can be multiple type of products, right? There can be a net banking processor, there can be UPI processor, there can be credit card processor, debit card processor, and many things like that. So we don't know which processor user will be using. So in such situations, we can have a common interface called payment processor, and we can have the classes implemented as the need arises, right? And to create these products, we will have their respective factories. So net banking factory will create net banking processor, UPI factory will create UPI processor, and if there are more, we can keep on adding to this, right? So we have the abstract factory class, which will have one method, create payment processor. This can be any name that we want. And the child classes are responsible for creating the respective and correct product as per the user needs, right? So these are the diagrams for factory method pattern. Now let's try to understand all this using code. So I've created a new folder called factory method and we are in the factory method.cpp. Let's try to understand this. So as per the diagram, we need one interface payment processor which has one method process payment. So that is this one. We have a payment processor method and it has one method process payment, which is virtual void, which means that it is an abstract method which any child class can implement, right? This is a general destructor which we will use to delete the object after it is done, right? Now what is the next step? Next step is to have a net banking processor which will implement this interface. So that is this piece. So this is a net banking processor which is implementing from the parent processor, and it is implementing the process payment method, processing net banking payment, right? Similarly, we have the UPI processor, which will also implement the process payment method, and it will say processing UPI payment, right? So this side of the functionality is done. Now let's create the factory side of stuff. So for the factory, we have a base abstract class, payment processor factory, and it has one method, create payment processor. So the responsibility of this factory is to create one of the relevant products. We don't know what the product is going to be, but we know that when we are calling upon this method, it will create the relevant object for us, right? And we have two classes which are inheriting from this. We have the net banking factory class, which is inheriting from payment processor factory, and it is implementing the create payment processor method. And what is it doing? The sole responsibility is to create the corresponding object. So in this case, we are creating the net banking processor, which is here. So we are creating the object for this, and whoever needs this object can process payment for net banking using this. And similarly, we have the UPI factory, which is implementing the parent payment processor factory. And this is also applying the create payment processor method, and it is returning the UPI processor object. So UPI processor is another product of ours, and we are creating the object for this one. Now let's see the usage. So let's say our main is our client, and main is asking the user to choose a payment method. One is for net banking, two is for UPI, and so on. So once we have the input, we can use a switch case to call upon our respective factories. So in case of one, we will call upon net banking factory, and net banking factory will create our payment processor using our create payment processor method. Once we have the processor, we can simply call upon the process payment, right? Similarly, if it is case 2, we will call upon the UPI factory. UPI factory will create the respective payment processor for us, and it will return the payment processor object. And once we have that object, we can use that object pointer to call upon the process payment method. Similarly, if we have a third case, we will keep on adding to the cases here. So this is a code implementation. Let's run and see how this looks like. So we can choose a payment method here. Let's say I'm choosing net banking, and it is processing net banking payment. And if I run it again and if I choose UPI, it is processing UPI payment, right? If I do something else, it will simply say invalid input, right? So this way we can give the choice to the user, and the creation of the object is abstracted away from the user, from the client, and we are able to process any type of payment using this type of pattern, right? So this is a typical implementation of the factory method pattern. Of course, there can be variations of this, and here in my case, I have not used any implementation for this create payment processor. But if you want to add some code here, you can do so and make it an abstract class. And if there are any other methods inside the factory which are required, we can add them here, right? So it's a little flexible in this way, but the whole idea is to abstract away the object creation process and delegate it to child classes. So that was the original intent behind this, right? Define an interface for creating an object, but let subclasses decide which class to instantiate, right? So that's the whole idea behind factory method pattern. So far we have covered the intent, the example use cases, we have seen the diagrams of the implementation, we have also seen the code. Now let's talk about some of the trade-offs. So in factory method pattern, we get loose coupling because we are not dependent on the parent class. We can choose whatever child class we want and that will create the respective object, right? So we get kind of loose coupling here. And it supports open close principle because we can keep on adding any number of products without altering the main interface or the main parent class, right? And it also supports single responsibility principle because the whole object creation logic is given to factory method and the implementation logic is given to the child classes of the products. So this clearly supports single responsibility principle. And it also supports the dependency inversion principle because the higher level module, the payment processor, is not dependent on the lower level module, UPI banking, net banking, UPI payment, and so on. Both are dependent on common abstractions. So that's why we can see the usage of dependency inversion principle here as well, right? So those are the good things. Let's look at the weaknesses now. So with factory method pattern, we need to deal with two levels of abstraction, right? First, the factory class itself, which will take care of creating the respective child classes for the factories, and then the interface, which is also abstracted away for creating the actual product. So this way the code complexity has increased in this pattern. That is something to keep in mind. And then we have many subclasses to handle. As we keep on adding products, as we keep on adding factories, there are many subclasses to handle. So that is also something to keep in mind. So the code becomes huge. And it also becomes harder to debug because if something goes wrong, we need to first check, okay, which is the factory, and then we need to go to the respective product, and then we need to go into the respective implementation of the product, and then we'll see where the issue is, right? So it becomes slightly harder to debug, but there are also very good advantages for using this pattern, and it is widely used and popular pattern, right? And these are some trade-offs to keep in mind. So if you have come across any other trade-offs like strengths or weaknesses, definitely put them in the comment below so that I can learn. Anybody who's watching the comments can also learn, right? So we can keep this engaging. So those are the trade-offs for using this pattern. So that's all I had for this video, guys. Thank you so much for watching. If you have any questions about the factory method pattern, definitely let me know. Don't forget to subscribe if you haven't done already. Do leave a like if you found this video helpful. Thank you so much for watching. I will see you in the next one. Cheers.